Today, inshallah, we're going to continue on PACS. We're going to start with the display workstations. Basically, the display workstations are the interactive part of PACS, meaning that it's the part that the physicians deal with. Okay, it consists of a monitor and a computer, and usually with the computer you have mouse and keyboard in order for the doctor to be able to annotate images and measure things, and also modify things if he needs, and also in order for him to be able to write the report. Okay, so basically it's just a computer. But actually the big difference between this workstation and a regular computer is the monitor. Monitors in PACS are much better than the usual monitors that you would encounter with your personal computer, basically. Usually they look like this. They are basically vertical. They are not, the aspect ratio is not like 16:9. It's the opposite. Usually it's like this because basically doctors are used to the way of looking at images like this. And if they have an image of usually the radiographs look like this also, the aspect ratio looks like this. So basically they prefer the monitors to be like this. Usually for each one of these workstations, you have multiple monitors, okay? The initial, early in the history of PACS, doctors were used to using lamps. So basically when you have lamps, you have two lamps like this. So basically you can post like 8 radiographs, for example, and you can look at them all at the same time. So doctors were used to looking at multiple images on the lamps. Okay, so basically they expected that they will need something like that when they go to PACS. Okay, so basically they are transferring their knowledge or their experience from the regular lamp to the PACS system. Okay, so basically they thought they need 4 to 6 monitors in order to be able to basically match the viewing capabilities that they had with light boxes. Light boxes are like this. These are like the light boxes. Okay, basically they light these and basically it's split like this. And basically if you put the radiograph in front of it, the doctors can see the details of a radiograph. Okay, so basically they require actually that multiple monitors like this are used in PACS systems. So basically at the beginning, people use from 4 to 6 different monitors, for each workstation, so that doctors would feel comfortable, viewing the images on PACS. But as the radiologists became more comfortable viewing images on monitors, the number of monitors required by the radiologists has decreased to an average of 2, basically. Okay, so basically this is also attributed in part to the continued development of viewing software and better hardware. Basically, these monitors are not regular monitors. Basically, if you buy a computer monitor for like maybe 1,000 riyals, something like that, you can actually get one of these for maybe 20 to 30,000 riyals, something like that, at least. Okay, they are much more expensive. Okay, when they first started, by the way, these monitors, in order for them to have the required resolution, you would get a minimum of $15,000 per monitor. So if you use 4 to 6 monitors, this means that you have a fortune there. Basically, you can have, if you have 15 times 4, it's like $60,000 there. Okay, so it was really expensive to have such a large number of monitors. But now we have only 2, and basically the cost, of course, went down a little bit. And basically the quality of the monitor itself became a little bit better. So basically they are much better right now. Okay, so basically now the usual is to have 2 monitors per workstation, okay, for each one of the display workstations. But we have to understand that the monitor is the most expensive part. Sometimes the software that is used to view the images is also expensive because it allows the user, as we're going to see in a second, it allows the radiographer to basically manipulate the images so that they can see the small details in the image. They can magnify, they can focus on certain areas, they can change the contrast, they can change the brightness, you can change everything basically using these software packages. Please, if you have any questions, just stop me and ask whatever you want, okay? Usually, it's not just the display workstation that the PACS system will have. Basically, there are 4 types of workstation that you should expect to see in a PACS system. The first one is the radiologist, which is what we were talking about in the previous slide. Basically, you have these monitors. These are the display monitors for the images. Usually, you have a regular computer monitor just for the software. If he wants to write a report or something like that, he can write it here. So basically, these are different. These are just for displaying the images, because actually the quality of monitors required to display the images is different from those that are used in commercial PC systems. Okay, this is one of the tasks that you will be assigned to actually read about. Basically, write about the differences between the medical grade monitors and the regular monitors. There are huge differences, by the way. Okay, so basically, this is the radiologist. This is the most expensive workstation in the PACS system. Usually, for each physician, basically, if you're talking about the PACS system, it's installed somewhere in a hospital, and you have physicians, and these physicians are the ones who ordered the radiograph to be done in the first place. So basically, whenever the radiology is done, whenever the radiograph is taken, basically, the images are sent back to the physician in order for him to complete his diagnosis. And basically, if he is going to assign a certain treatment to the patient, he can do that. So basically, there is a regular monitor. It doesn't have to be a medical grade monitor in this case, because the physician is not a trained radiographer. So basically, he cannot read the images just like the radiographer would do. He only needs to look at the reports from the radiographer and basically look at the basically annotations from the radiographer on the images. So basically, he needs to just basically be able to view the report and the associated images along with the report. So basically, doesn't have to read the original data or the original images just like the radiologist. So basically here, as you see, it's a regular monitor. This is not a medical grade monitor. Sometimes you have a workstation for the technologist. Basically, the technologist is the one that does the radiographs. Basically, he's the one that actually operates the X-ray system and basically collects the images and then sends the images to the doctor. Okay. Usually, this technologist is usually not only just does the images. Basically, he has to do the quality control. Basically, for that particular imaging system. So before he operates the system, he has to do some quality control checks. He has to put like a phantom inside the machine and take an image of that phantom and take some measurements, things of that sort, so that he can basically do like a regular check, like regular daily check on the system before he uses it on patients, just in case there is something wrong or the images come up with something that doesn't look right. He can actually detect that before he starts basically applying the system to patients. So basically, it would have a regular computer system. This doesn't have to be a high-end computer system, and this doesn't have to be a medical grade monitor. But basically, the technologist uses this system just to display the images from the phantom and take some measurements so that he can basically confirm the quality of the system before he starts the work list for that machine. Okay, so for each machine, he should do that. Each technologist assigned to a particular imaging system should actually do the quality control, the required quality control for that system. Okay, so basically, this workstation is used for that purpose, for quality control. Sometimes you usually have something called a file room system. Okay, this is intended for some cases. In some cases, you don't have everything in digital format. Okay, so all the if you have all your digital system, if you have all your imaging systems as digital imaging systems, then you don't have to have a file room. But in some cases, you have some of your imaging systems, like some of the legacy imaging systems, the imaging systems that were installed a long time ago, and they are still working fine, and it doesn't make sense to replace them. Sometimes you're still working with some films from some of the modalities that you have. Okay, or if you have some of the imaging systems that don't have a digital interface. Okay, so that you can get a film, or you can get an image print out, and basically this is all you can get. You cannot convert it to digital. It doesn't go directly from the machine to the network or the PACS system directly. So basically, you have a workstation in what's called the file room. This is called a file room, but it doesn't really contain everything. It contains only the images for those systems that do not have a digital interface. And usually, you have some kind of a scanner that allows you to scan a film. Okay, and you enter that film into the digital system, and you basically assign it to the right patient so that you can have everything in a digital format for every patient you have. So basically, it's like a conversion or like a gateway for films or film-based radiology systems into the PACS system. Otherwise, you will have two independent and two parallel systems, one using films and one using digital images, and basically it's extremely difficult to work with two such systems. So basically it's better to just take the images, take the film that you have and convert them to digital, and basically ask the radiologists even to look at them in the digital format rather than the film format. So basically, each one of these is a different workstation. It has different specifications. Mostly for these systems, basically for the file room system, the technology system, the physician system, they are usually regular computers. The only one that is different specifications is the radiologist one, which is the display workstation that we were talking about, which has to have medical grade monitors. Medical grade monitors are extremely high resolution, extremely high brightness. They are very expensive. They are really, the color reproduction there is really calibrated so that you don't really have differences in colors between different times and different monitors. Basically, it's a much more controlled and much more high quality monitor than the regular monitor that you use on your PC. Here for the PC, you don't really care about the colors, the color calibration. If the red is slightly off red, it doesn't really matter, okay? For these images, basically, if you have the slightest change between the different color or RGB, because you have here grayscale, the images might look a little bit different, which can be really difficult for the doctors to basically observe. And basically, you have to actually do the calibration, and you have to make sure that the way the images are displayed are also calibrated. So basically, if you have a gray scale or a gray level of 100 and a gray level of 200, you have to see basically the difference between these two exactly the same for all monitors. Okay, so these are the most expensive components. In the file room, probably the scanner might be a little bit expensive, but now they are not as expensive as they used to be. But otherwise, all the other computers are not that expensive. Usually for each one of the PACS workstations that you have to have certain common functions, okay? First of all, you have to have navigation functions that allows you to move through images, series, studies, and patients. So basically, you have a list of patients like this, and basically you select a certain patient, and basically select a certain study. Basically, you see here the name of the patient here. You can enter the patient, and then within the patient, you might have more than one study. For example, if the doctor asks the patient to do an ultrasound and a CT, okay? So inside that patient, you might find two studies, okay? And then inside each one of them, for example, the ultrasound, you might have more than one series. Series is a collection of images that are done in a particular situation, okay? For example, if you're talking about ultrasound, maybe the doctor was looking at the liver for a series, and then he was looking at the kidney, for example, and taking some measurements. And then he was looking at another area as well. So basically, each one of them is considered a series. Within each series, you might find more than one image. Okay. For example, if you look at the liver, you might take actually more than one view of the liver and basically put them as images inside the series. So basically, the navigation functions would allow the doctor to basically treat each one of these patients as a folder, and each one of them will have subfolders with studies. Each one of the studies will have subfolders as multiple series, and each one of the multiple series will have images. Basically, you can look at the images there. He can actually have a customizable work list to navigate through these patients. Basically, you can actually basically put the work list. Basically, we said before that one of the advantages of the client server topology is that we have a centralized work list, or basically they assigned each doctor a certain number of patients, and basically this doesn't conflict with any one of the other doctors. Okay, so basically for each one of the assigned patients, he can actually start with the ones that he prefers. For example, if he wants to start with the images that are, for example, coming from MRI, for example, first, he can actually customize the work list to do that. Okay, you can also customize the way it open, each one of the series would open. Okay, so for example, he can actually basically customize the what's called the hanging protocol. Hanging protocol is taken from the time where we have the light, the lower light lamp, basically. When we have actually put the radiograph there, they would hang it there. Basically, would just insert it here, and it would be inserted, and basically he looks at the images side by side. So basically, the way you look at the images together is called the hanging protocol. Okay, so basically you can choose like side by side like this. You can choose 4 images. You can choose more than 1 image, more than 4 images. You can choose exactly what you want. You can have the current study here and the basic on one monitor, and you might have the previous study, some images from the previous study in another monitor, for example. So basically, whenever he wants to open a certain patient, he can actually customize the way these images are displayed for him, the way he likes them. Okay. And basically, you can have study navigation where images can be paged through with keyboard and mouse. So basically, if you have a series, for example, series of images, basically, you can actually go through these images using a keyboard or a mouse. This is actually one of the things that are very similar to what we do, actually. If you have a set of images on your computer, you can very much look at them and basically browse through them using your keyboard, like the arrows, or you can use the mouse, so that you can go through the different images. So basically this is not uncommon, but the other ones related to the work list and how the images are displayed, these are very much related to how the doctor wants the images to be like, in order for him to be able to work with them comfortably. Usually for each one of the PACS workstation, you have a set of image manipulation and enhancement functions. This is also one of the things that you're going to do in the project related to this part. I'm going to basically refer you to one of the open source packages that are used for this. And basically going to do some of the very simple manipulation and enhancement functions. For example, window and level. Okay, window and level means that basically for the window, you're talking about the range of gray levels that you're going to have within your image. Okay, so basically if you have a histogram is basically here, this is a gray level, and here the number of points in the image that has this gray level. So basically usually you would end up having something that looks like this, for example. Okay, so this gray level, basically this curve actually is called a histogram because it shows you the distribution of gray levels in your image. So sometimes, for example, for the CT images start from -1000 up to almost 3000 or more. Okay, so this is a very huge number. Basically, you have a difference between these two of 4000, and it's very difficult to display it like this. This area here is related to things that contain air. This area here is related to soft tissue and water and blood. And this area here is related to bone. Okay, so basically if you want to focus on one of the areas that has bone, then you would actually focus on this area. So basically you choose a window. This is a window. This is like a window. The level is the center of the window. So basically you can move this basically from here to here. For example, if you want to look at the soft tissue, and you can move it to here if you look if you want to look at something that contains air, like the lungs, for example. So you can select the window and the level, and these are very simple actually. It is done almost, it's like you do it by nature basically. It's like you know, if you imagine yourself moving your mouse, they actually use this as if you are playing with the mouse basically. It's very easy for them. Okay, and basically the way they do these or work with these is basically they need to see the images look like this. Basically, if you have an image that looks like this, using the window level, you can actually make it look like this, which is much clearer actually. Okay, so if you do that, then you're going to be able to basically are going to be able to diagnose the images much more precisely. So these are very important manipulations that are used with the images. In another course, actually, the 684, we used to actually do these things as a part of the course. So basically, this is one of the things that you might want to consider if you're interested in image processing. So basically, here we're just talking about them as just the functionality, but actually in the other course, you used to actually implement them. So these are very important. Annotations are extremely important. For example, he can come and write something here. The annotation is like you put an arrow, for example, this is annotation. I write some text, this is an annotation. I basically highlight something like this. This is kind of annotation like this. I put some measurements here. These are all annotations. These are very important because as I said before, some of these images will go to the referring doctor. The referring doctor would like to know exactly what you saw in these images. Okay, so basically when you have an annotation on the image, it would make his life much easier. Okay, sometimes you like to flip and rotate the images. Sometimes you like to see the images in a particular way. Okay, for example, if this image was, image like this, for example, usually you'd like to see this as vertical rather than horizontal, this bone right there. If you prefer that, you can very easily rotate it. Flipping means that you change it in one axis like this. So basically it's like a mirror image. So basically you can do that. It's very easy, okay? All these things don't change the image. Basically, they just a way of displaying the image in a more comfortable way to the doctor. So you can flip or rotate, or together if you want to. You can also do something called panning or zooming or magnification. Panning means that if the image is larger than the screen, you can pan it. Pan it means that you shift the image so that you can see another part of the image. For example, if I magnify the image or if I zoom the image or magnify the image, basically the image will be larger than the display. So basically, after the magnification, the image is like this now. Okay, this is the display. Okay, if imagine the hand cursor that you see in some of the image display softwares, it's basically just to pan the image. Basically, you can move the image so that you can display a different part of the image on the screen. Zooming, of course, is basically making the image larger. Magnification, you can sometimes have something like a lens. So you can basically have a lens, a part of the image magnified like this, so that you can see it clear. Instead of magnifying the whole thing, I magnify only the part that I think is more important. You can also do measurements, which is actually what is displayed here. As you see here, you have a line. And basically, when you do that line, you actually get the measurements, the actual measurements in the physical units, basically. You see here, the dimensions in centimeters appear here right away. Okay, you can also, instead of just measuring distance, just a straight line distance, you can actually measure a curved line. You can also measure an area. You can also measure a volume. Depending on the situation, you can do a lot of things. So all these things should be available in a PACS workstation. These are extremely important, and that's why the imaging software is very important. Okay, the imaging software is responsible for making the doctor comfortable and basically providing the tools for him to be able to examine the image more thoroughly. So basically, this is extremely important to have in a PACS workstation. This is one of the things that we're going to see, and basically, I'm going to send you a software link that you can actually download and basically tell you to do a few things so that you can be familiar with such things. Sometimes you should have also image management functions, okay? Meaning that you can actually do some of the things that are what we call administrative actions on the PACS system. For example, modification of the patient demographics. Demographics is basically like whether the patient is white, black, Hispanic, whatever the demographic that he belongs to. Basically, you can actually sometimes modify these through the image management functions. It's not just the demographics, you can actually change the patient data, but actually this would require an administrative password. Not anybody can actually do that. It shouldn't really be allowed for anybody to do that, because if it's like that, then basically the traceability of who did what would be really difficult. And you shouldn't really allow anybody to do that. Somebody who is in charge and who is going to be responsible for the changes should actually do that change. You can also, this is very important, so basically this is not as important, this is very important, which is query and retrieve study. Meaning that you're not just looking at the work list that was sent to you. If you have a certain patient on your work list and you'd like to query if there was a previous study for that same patient, you should be able to do that. Query meaning that you're basically asking the system or doing a search on the system if there is a study for this patient. And once you get the query results, you can actually select the study that you'd like to have and retrieve it, so that you have the old one with the new one, so that you can basically check if there is any change over time, or basically if what you're seeing here is normal, or if there is something that looks abnormal, you'd like to see if it was there before, and if it wasn't, or was a little bit smaller or a little bit larger, you know exactly where this is going. So basically this is very important for the doctor to perform the correct diagnosis. Sometimes you can actually do CD burning option, meaning that you can actually get a CD with the images or the study of the patient. Okay. Sometimes if you want to give the patient or basically give your report along with some of the representative images to the patient on a CD, so that he can take it to a referring doctor outside of the hospital, you can do that. So instead of giving the report just on paper, you can actually give some of the images on a CD, so that if the referring doctor wants to see them, he can do that. Usually for this CD burning option, it would not only put the images, it would also put the viewing software on it. So you don't have to wonder how it's going to be open, or whether the doctor will have the right software to open it. No, usually on that same CD, you will find a reader or an image viewing software. Of course, it's going to be as a light version. It's not like the fancy one that is used for the doctor to do the diagnosis. It's just for display. And usually it's given by the same company that does the original software, but it's like a light version or a free version that would be free to distribute to anybody. You can also, if you're actually writing your report, it allows you to copy and paste images into a document. So basically, this is very important to include some of the images in the report, okay, which is maybe seems basic to you, but actually, if you imagine that this PACS software is very complicated, it's not really, it's not like what you would see actually in your PC with a Word file or something like that, basically, or the report. Even the reporting software might not be as easy as the Word document, that you are used to using. So basically, this is actually a very important function. You might also select to print a film, okay? Usually we want to stay away from films, but sometimes if you are going to basically send a report to somebody who is outside the hospital, sometimes you're afraid that this doctor might not have a viewing software, might not have a computer at all. In some rural areas, you might not actually find many computers in the whole area. So basically, sometimes the doctor, the referring doctor, asks specifically to receive a film, rather than he wants to have a hard copy image rather than a digital form of the image, because he doesn't have a viewing software or doesn't have a computer that is capable of doing that. So basically, you might need to print a film for that. Okay, so basically you will have an interface that will allow you to actually select, for example, if you want to send one image like this to the printer, or basically you can actually divide this area into, for example, 6 images. It depends on whatever you want to include for the doctor. So basically it has a lot of options that you can choose from. There are some advanced workstation functions. Advanced means that they might not be available on all workstations. So not all workstations would be able to do the things that I'm going to tell you now. Okay, so basically some of the advanced functions for the reading workstation might include multiplanar reconstruction. Multiplanar reconstruction meaning that basically if you have a certain set of images taken like this, in this way, okay? Imagine that I would like to reconstruct an image that looks like this out of these images. Basically, I have, for example, 100 images, for example, okay? But I want to look at this direction. Can I do that? If you have multiplanar reconstruction, it allows you to reconstruct an image in any direction from this set of images. So basically, I have a set of images, and this set of images, basically, it's essentially a volume, or basic slices out of a volume. The multiplanar reconstruction allows you to reconstruct an image in any direction you want. So basically, if you want it like this, you can get it like this. If you want it in another direction like this, you can do whatever you want. So basically, it allows you to slice through the volume the way you like. This is not volumetric imaging. Basically, it's not going to show you a volume, but it basically allows you to slice through the volume and get an image in any direction you want. This can be very important because some of the structures that you are interested in might be in between images, or might be distributed through multiple images, multiple of the original images. So basically, might be here and here and here. You want to see the whole thing. So basically, it's better to just have an image that passes through them and basically see the whole structure, rather than looking at the different images in order for you to be able to see exactly where it is. Okay, so this is very important. Okay, you might have something called maximum intensity projection. Maximum intensity projection is something that is used to do something like this. Okay, this is in particular very, very important for MR angiography. Basically, for MR angiography, the way basically something called white blood MRI. Basically, it's like one of the techniques that would make the blood vessels look a little bit whiter than the regular tissues. So basically, if you have the blood vessels look a little bit brighter than the surrounding tissues, if you do the maximum intensity projection, you basically, for each one of the images, basically, you project in a certain direction. I usually project a volume, the whole volume. Usually for all the advanced workstation, you're usually working with a data set that scans a volume like this. So basically, if you have a very bright object here, okay, if you actually do a regular projection, then it will be added to things here that have nothing to do with it. But if you actually take a maximum intensity projection, then you're projecting in this direction, but actually what you're going to put here, not the sum, you put the maximum value. So basically this will come here and be very bright here in this image. So basically this way you can actually look at the vessels without the surrounding tissues. You can get a much better image for angiography if you use something like this, like a maximum intensity projection. This might not be clear from these images, but what I'm going to do is I'm going to put some samples from a maximum intensity projection in the resources part of the Blackboard page for this course, okay? So that you can look at it and see exactly how it looks like, okay? So this is very important also for angiography in particular. Angiography is imaging of vessels. Usually you can actually do something called volume reconstruction technique, which is basically reconstructing the whole volume, basically. And sometimes basically there's a difference between volume reconstruction and shaded surface display. The difference between these two is basically for the volume, you're basically showing the whole volume. Basically, you can slice through the volume. Basically, you can imagine that this person, this head right there, you can actually decide to look from any particular slice. So basically, I can, if this is the person, for example, okay, this is the nose, okay, you can actually cut through here and look. This is volumetric imaging. For the shaded surface display, you can display something that looks like this. You can select the bone. Basically, this is also the same thing. You can select the bone and display it as if you're putting a certain light somewhere, and basically you see it as a shaded surface, so that you can see it in a very realistic manner. Okay, so basically this is used to display the bone, for example, things like that. You can use it also for such things as if you want to display the face of the fetus, for example, for the pregnant women, you can actually get a volumetric scan for the child, for the fetus, and basically you can display the baby face, for example. Okay, so this is actually an example for the shaded surface display. Volumetric reconstruction is different. Volumetric reconstruction is as if you have an orange in front of you, and if you want to look at what's inside, you cut it and look inside. This is different. Shaded surface, basically, it identifies certain tissues inside the images, for example, the bones, and then basically removes everything but these things and basically displays the surface of the bones, for example, or the surface of the baby face, for example. So these are very important functions, but they are definitely advanced. You don't have to be in every workstation. Okay, it depends on the kind of imaging systems you have. It depends on the kind of cases you have. It depends on the basically the kind of patients or the interest from the patient to have such fancy things like the shaded surface display, so that it can actually be of practical value to have such advanced workstations. Sometimes you might have some advanced functions in the technology's quality control stations, like stitching multiple images into one. This sometimes you might find something like that also in the regular workstation, but it's sometimes very important to have something like this in order for you to be able to, if you want to scan a very long object, for example, that doesn't fit within the imaging system, you might take multiple images and then fit them together or stitch them together. Stitching them, meaning that I'll take this and put this right by it. They say that stitching, there is no actual stitching, but it's like you basically connect them together so that you can become one. So instead of having just this one and this two, you have just one image that is basically composed of the two together. Sometimes you have image post-processing that might be used by the technologist so that he can detect any artifacts, for example. Okay, so basically, if he sees something that might not look right, he might use image post-processing like filtration, like noise reduction, things of that sort, in order to investigate if there is a problem or not. Okay, so these might be in the quality control workstation, but it's not really very common because this would require a very large, what I should say, physicist. Basically, you have to have an experienced physicist or an experienced technologist so that he can do that. This is not something that any technologist would be able to do. So basically, these are kind of advanced functions that might be available if you have the right expertise to use them. Usually you have something called image manager. This is basically like the master database of everything that is in archive. So basically now you're getting images from, you have 50 imagers, and basically each one of them generates basically gigabytes over gigabytes and terabytes over terabytes of data. And you're storing every one of these studies under the relevant patient, and basically you're keeping them somewhere, and this somewhere is usually the archive. you should have a master database of everything you have, so that when you try to query, you query that database. You're not supposed to be looking at the files and things of that sort. You're supposed to be looking at a master database that has the information of what is stored in the archive. Okay, so basically it's like when you go to Google, okay, when you search for something, you're not searching all the websites in the world. You basically have a database at Google, and this database is updated with whatever gets changed on the web. So basically you're querying the database and basically getting the results, and then when you get the results, you choose where exactly you want to go. Okay, so basically this master database is basically extremely important in order for the functionality of PACS to be done properly. So it controls the receiving, retrieval. Basically, if you have receipt, meaning that images coming from the imaging systems to the archive. Retrieval, meaning that the images going from the archive to the physicians. Distribution of images, meaning that the images basically are distributed to the doctors who are assigned to basically write the reports or whatever, okay? And basically it also controls all the DICOM processes running within the archive. The DICOM processes, we're going to talk about it in a dedicated part of this course. This is basically one of the standards for the image formats. And it's more than an image format, as we're going to see. It's a whole standard, and it doesn't contain only the images. It contains the images, contains the information about the imaging system, the imaging conditions, the patient information, the manufacturer information. It's a lot of things. Okay, so basically the DICOM format has a lot of properties or a lot of processes that must be running in order for you to be compatible or compliant with the DICOM standard. So basically all these must be actually done using the master database. Okay, so basically you have a lot of things to take care of using this image manager. Basically, usually the image manager is implemented using a reliable commercial database. It's not like you're going to invent a new database for something like this. Okay, so it's usually a commercial database, and usually use something like structured query language or SQL, okay, to be able to actually query whatever it's in the database itself. So basically, usually you query based on the image header information, not the image data. Okay, maybe 20 years ago, actually, there was a lot of research about content-based retrieval. Okay, so basically, people wanted to add to the PACS systems the ability to, for example, if you have a certain image, okay, and you would like to see images that looks like this image, okay, this was actually one of the hot topics maybe more than 20 years ago, and it still is actually, but you don't really have a reliable system that would be able to do that. And actually, unfortunately, also it's kind of resource consuming. Actually, it requires a lot of resources to be able to do that, because basically once you established a PACS system, the storage itself is huge. Basically, imagine that you're adding to your storage many terabytes of data every day. So basically, after a few years, it's extremely difficult to imagine that you're going to do any processes on all the images. Okay, it's much easier to look at the image metadata or the image header. Image header meaning that the regular information about the scan itself. So basically, if you're talking about the patient information, talking about the type of scan, whether it's a CT scan or an MRI scan or whatever, within each one of these modalities, you might also want to have if you have MRI, for example, whether the scan was T1 weighted, T2 weighted, the kind of information that you have about the scan. So basically, all such data is not going to be very large. So basically, you can actually store them in a reasonably sized database, and you can query them relatively fast. Okay. So basically, this is actually what is done right now. And you're doing that with the regular database systems that are used for very much any other application. Okay, so basically, you imagine that the images, instead of having the images inside the database, you just have a link. You basically store the images somewhere and basically include only the link to these images within the database. So basically this makes the database size relatively small, okay? If you're going to add the data, then it's gonna be extremely difficult to deal with, okay? So basically image data are stored on the archive server, and basically you have all the information on a database that is accessible, and basically you do the query, and basically you might have multiple systems that are actually querying the same database at the same time, and you still get a relatively fast response. So basically this is very good design actually. In order to make sure that we talked about this before when we talked about client server, we talked about the server as a single point of failure, and basically sometimes if the database on the server, or if the server is down, for example, you might have a problem. In basically everything would stop. Basically, you're not going to be able to do anything in the client server system. So usually you have another server, and usually you have a database that is mirrored. You have two identical databases running simultaneously, so that even if you have both servers running, basically you can actually query any one of them, basically. So basically this will actually allow you to have, basically if one of them fails, then the other one will still be there. So basically the system doesn't stop, okay? So basically if one goes down, the system can still call on the mirror and continue to run as normal, which is a very important feature for client server systems, basically in particular, okay? The image manager also has to have an interface with the RIS, Radiology Information System. This is the next topic we're going to talk about, inshallah. It's a part of the HIS, Hospital Information System. Okay, Hospital Information System is the general umbrella that has under it several other information systems that are related to, basically they are together, are basic part of the HIS. The RIS is a part of the HIS, as I was saying, basically. And usually when the patient goes to the hospital, he would register on the hospital information system. So his information is now in the HIS. If he's referred to a doctor or basically referred to the radiology department to do a scan, then he would go to the RIS. Basically, his information would be registered on the RIS. RIS, as we're going to see, is basically responsible for scheduling the scan, okay? So basically, there's a difference between basically doing or taking the images from the scanner and putting them in the archive server, and the diagnostic process after that. This is not related to the RIS. The RIS stops at the moment the scan starts. So basically, it takes the information from the HIS and schedules the scan on the particular scanner. Basically, it manages the scheduling of tasks on different scanners, and basically schedules this patient on this scanner, and whenever this is done, the function of the RIS is done. Okay, after that, the PACS basically takes the data and saves it and distributes it to the doctors and gets the reports from the doctors. And after they do that, actually, it is sent to the RIS or the HIS. It depends on the kind of information or the kind of arrangement that is used in the hospital. But usually the report is sent back to the RIS, and it is sent from the RIS back to the HIS. Sometimes it goes directly to the HIS, so that this report goes to the patient file, to the EHR of the patient. Okay, so basically you need to have that interface so that you can get the information. Whenever you're doing a scan, you have to get the patient information and include it with the images. Okay, so that when you save the images to the archive server, you save it with the full patient information, so that when the doctor retrieves the data and does the report, or basically does the diagnosis, he has all the relevant patient information that he needs. And basically, after the report is done, basically you populate the EHR of the patient with that report. Okay, so basically there is an interface at the beginning, at the end, and at the end of the PACS process, so that you can get the information of the patient, and at the end you basically put the report in the EHR of that patient. there is a very important concern about the reliability of the data, basically reliability of the storages. Okay, if you're talking about regular hard disks are usually basically they sometimes fail, basically, especially if they are mechanical. Basically, after a while, you have to expect that at least one, if you have a large storage area, if you have a large number of storages, then at least one of them will basically go down every month, for example. Okay, so basically, it's very important to consider the technologies available to use for such huge storages as the archive server. Okay, so basically, we're going to divide this into two different parts, or two different technologies, two different sets of technology. Okay, the first one is what's called short-term storage, which is intended for example, if you want to have if you have a patient, for example, patient data, if the images are coming from the scanner right now, you maybe want to keep this for at least a month. Okay, or maybe sometimes you actually keep it for a year, just in case this patient is basically going to basically do some more investigative studies or something like that. So you want to keep his data a little bit handy. Okay, so if you, just in case you need it. Okay, so short term is not doesn't mean like one day, for example. Talk about months or sometimes years. Okay, the most reliable, or basically the most widely used technology for short-term storage is what's called redundant array of independent disks. Sometimes the instead of I here, because RAID, sometimes the instead of E independent, I independent, you call it inexpensive. They are actually very much independent and inexpensive at the same time. Okay, so basically, instead of buying a specialized hard drive that has very high reliability, use regular hard drives, like the ones that you would go to the computer mall and get them from there, for example. Okay, the problem with such disks is that basically are not reliable. They can actually fail. But actually, if you use a redundant array of independent or inexpensive disks, the RAID storage, the RAID is arranged in such a way to allow you to have the same data written in multiple disks. Rely on a very important criteria is that usually when things fail, only one thing fails at a time. It's very unlikely for two things to fail at the same time. This concept is used in many industries, by the way. Imagine, for example, your car. How many spare tires do you have in your car? You have 4 spare tires? You have 4 tires, right? How many tires do you have? How many spare tires? You only have 1. Why only 1? Is there a chance for you to have 2 spare tires, two flat tires at the same time? It is possible, but it's very unlikely. Okay, so basically the most economic, and at the same time, basically it's according to the laws of chance, basically it's very reasonable actually. It's very easy to assume that you have only one fault at a time, which is basically called single fault tolerance. Or single fault tolerant design. Okay, so basically if you have your data distributed over a number of hard drives, so that you have at least 2 copies on different disks, then if one of them fails, then it's very easy for you to just compose whatever was on the failing disk from the other ones. So basically this RAID, or array of hard disks, you can actually have you can accept a number of them to fail without actually losing your data. And there are actually several levels of RAID. Basically, I'm going to talk about them in a second. But actually, depending on the RAID level, actually, you can allow multiple things to happen. Basically, you can allow in one of them, you can basically accept that, or basically tolerate the failure of more than one drive at a time. Usually, use technologies called striping, mirroring, and error correction. basically. Striping means that you are basically saving the data basically on different disks. So basically you have, instead of having your data, the whole block of your data or of your certain data block you have, instead of having the whole thing on one drive, you stripe it meaning that you have each part on a different disk. Okay? You might have mirroring, meaning that you might have the same part, mirrored in different locations. You might have error correction, meaning that you can actually detect if there is an error. Okay, if there is an error in your data, and sometimes you actually have error detection and correction. Okay, you detect the error and correct for it. And sometimes it is done, for example, if you have 1-bit error, if you have 2-bit errors, okay, and so on. And of course, if you want to have error correction, depending on the number of bits you want to correct, you can basically, the storage can be a little bit, much larger and much more complex and much more expensive. So basically, you have to be really careful with that. Okay, so basically, if you have something called Radiographer 0, okay, Radiographer 0 basically means that you're going to use only striping. Striping means that you're going to use two disks, and basically if you have 2 disks, then this striping would allow you to, if you have a regular hard drive that is very slow to access, basically if you want to read something from a hard disk and this hard disk is not very fast, then it might actually be a bottleneck for the whole system. But if you do striping, then if I'm dividing the same file into stripes, and this is present on disk 1, this is disk 2, this is disk 1, this is disk 2, and so on. Okay, then I can read 1 and 2 at the same time, because basically they are different disks. And then read 1 and 2 here at the same time. So basically striping allows you to double the speed. But actually, if one of the drives fails, then it would be a big problem, basically. So basically, if drive 2 fails, then you're not going to be able to basically get any file. So basically, it doesn't have, basically the cons here, or the pros here is that you have high performance, which means that you have higher speed of access. And the cons here is that the data is lost if one disk fails. So basically here, you don't have any redundancy. On the other hand, if you have mirroring, then basically mirroring means that the same thing is written in both hard drives. So basically, this is hard drive 1, this is hard drive 2. The same thing here, I put it here and there. So basically, you have mirroring now. So basically, for mirroring, you have fault tolerance. But the point is, here you can also have, because you wrote both of them here and there, you can actually do something like this. So basically, you can read this part first and this part second. So basically, you can also read in parallel. You read a part of this file from here and the other part from here, so that you can read them at the same time. So you can add here fault tolerance to high read performance. It's high speed and fault tolerant at the same time. The problem is you're basically dividing your storage by half, because basically if this storage is 1 tera and this is 1 tera, basically the combined storage of these is 1 tera, because basically you're basically copying everything in 2 copies in these 2 drives. So basically you have a disadvantage of this 1/2. Okay, so basically you have other versions of this, but the most important thing is I want you to know is just what's the meaning of striping and what's the meaning of mirroring. And there are other technologies that are used, like the parity, for example. I don't want to go into too much detail because this might not be exactly within the scope of this course, but there are some redundant array of independent or expensive storages, basically, if you choose, for example, RAID 1, if one of these drives fails, then you're fine. You can actually get the same content of drive 1 from drive 2. That's it. Okay, and it's very straightforward, actually. So basically, for people who have a drive RAID storage, basically looks something like this. I actually saw this myself. because I was working on a research center that was actually producing large volumes of MRI volumes every day. So basically, you had to do something like this. We have to use something like this. So basically, whenever a drive fails, the system would actually detect its failure and would tell you which one exactly failed. And all you have to do is just remove it and put another one. You don't have to do anything. The system by itself, the RAID system, operating system itself, would actually repopulate it with the data from the other drives. So basically, it's very nice to use, actually. Okay, so basically, this is one of the important technologies of storage that people use for imaging in particular. For long-term storage, we're talking about sometimes if you, for example, want to have all the images that you ever took for any patient stored somewhere, okay? You don't have to have it as immediately accessible, okay? But you need to have it somewhere in a digital format, okay? See, this is called the long-term storage. We're talking about here many years. So, for example, if you want to save images for 10 years, for example, okay? Or more than 10 years, okay? In this case, you cannot really rely on RAID storage. It's gonna be really too much, okay? But actually some hospitals that are not that large, they might actually use cost-effective RAID storages for both the short and long-term archives. If they don't have that large storage, basically, if they don't wanna have, if they don't really have that much capacity for the images, they might actually use RAID storage for both, okay? But actually, the more commonly used methods of long-term storage is basically using tape and magneto-optical disc or MOD, okay? Usually you have something like a jukebox. Jukebox is something like this, basically. You have the tapes like this here, and basically this is like a robot hand, and basically whenever you want to access a particular archive or a particular tape, for example, or a particular magneto-optical disc, usually here it's for tapes, basically you go and pick it up from here and put it in the tape drive and basically move it into the RAID storage. So basically it moves it from the tape format, which is really slow to read. Basically, once it is put back into a regular drive or a regular RAID drive, so basically it can be accessed very quickly from any workstation. So in this case, you might wait a little bit just for the tape to be downloaded or uploaded again to the short-term storage, and then you can access it as if it's a short-term storage. Okay, tapes, by the way, basically they look like. I actually don't have an image of a tape here, but actually it looks like, if you remember the cassette tapes that you had a long time ago, it's a smaller version of it, but it's very reliable and it's extremely huge in storage size. You can save a lot of things on one tape, okay? So it's very efficient, okay? Magneto-optical disc looks like this, looks like this basically, sometimes look like this, okay? And sometimes it's a little bit larger like this, okay? Sometimes they have other technologies other than MOD as well. So basically, sometimes it's of course, if you have things like that, you don't have a juke drive for them, okay? Or you don't have a jukebox for it. So basically, these have to be maintained by somebody, and basically is responsible for getting the data back from it if needed, basically. But jukeboxes are much more reliable in that perspective. Usually, long-term archives has much higher access times than the short-term archives, but price per gigabyte is much less. Of course, not talk about gigabytes these days, we talk about tera or even higher than that, okay? So basically, the price is much less per terabyte than the short-term storage. But the access times, if you're talking about a magneto-optical disc or any other storage, it's not as fast as a regular drive. So basically, if you want to retrieve the data, then it might take some time to put it on a regular drive, and then you can access it from there. Okay, but you really need to be aware of the kind of technologies used in that area. Okay. One important thing also is that some people use what's called application service provider. which is basically outsourcing of archiving and management functions for pay per use or pay per month charges. So basically, you can go to a certain cloud storage service, okay? It's not the regular ones that you use, because basically the amount of storage here is really huge. So basically they are specialized, and usually some of them are specialized in medical data, for example, or imaging data, for example. So basically, instead of having your long-term storage on-house or in-house, you actually hire such application service providers so that you can actually store your images over there. And basically, this is actually the kind of thing that we saw before in other things. Basically, we talked about this in some of the things that we talked about in cybersecurity. Usually here, you're not responsible for maintaining the data. Okay, we talked about how that need to have a backup and things of that sort, and you have to have it automatic, and you have to have it multiple copies and different places, things of that sort. So basically, you're responsible. If you're actually doing your own long-term storage, you're responsible for everything. But if you have an application service provider, it might be actually kind of expensive, and sometimes it's pay per use or pay per month. It depends on basically here, it depends on the size. Here it depends on the time, okay? And it basically it might have a combination of these, so that you can actually, remove that part or that responsibility from the hospital, okay? So it's very useful as a disaster recovery mechanism that keeps complete copy of archive in another location, whereby it is immediately available if frontline archive goes down, okay? So basically this I can actually not only use, you can actually not only use it for the present or the long-term storage, you can actually store everything in it, okay? So basically you have a copy in your short-term storage for the present images or the images that might be needed soon, but you still have copies of everything in that application service provider. So you have everything on the cloud, so that you can actually be sure that the patient data is not going to be in any danger anytime soon, okay? So these are all options that might be actually interesting to think about. I think we should stop here probably. We have a little bit of things about the film digitizers and film printers, and the difference between the kind of outputs we can actually provide to doctors. But I think it's better to just stop here. Inshallah, next time we'll continue that. And I think we should start with HIS so that we can finish it, and then after that we go with networking, inshallah. As you know, Tuesday, inshallah, is a holiday, and so we're not going to have a lecture. So our next lecture, inshallah, is going to be on Sunday. I'm going to try to post the new project for PACS. It's not going to be very difficult, and the people who actually did the second project actually they probably realized that it's not going to be that difficult also, hopefully, inshallah. It will not be like that. And the third one is easier basically than the first two. It's very simple basically. I just wanted you to have a practical experience with what is expected to be in a display workstation, and some of the other parts related to the specifications of the display monitor, the medical grade display monitors, so that you can know the difference between a regular monitor and a medical grade display monitor. Do you have any questions?
Dr. Yasser, I have another. I have a question, but it's in different about the bonus.
Go ahead.
I sent you an email, I think 3 days ago, for the first bonus, but I didn't see that. It did not reflect on the blackboard.
Actually, I didn't see. If I didn't reply to you, I didn't see it. Which email address did you use?
I think I used the email address that was mentioned in the blackboard.
It's ykada@kau.edu.sa.
Yes, I think so.
Okay, can you please send it again to me, and make sure that you send it to the right address?
Okay, I will resend it now.
Okay. If
Thank
you don't, just you can send it to me by WhatsApp, or you have my phone number also, just in case there is a problem. Sometimes if you send it to the university server, it has a very unusual way of classifying emails as spam. So basically, I haven't experienced that before, but actually some people actually mentioned that some emails got lost because of that. So just in case, you can send it to me by WhatsApp, but definitely you're gonna get your bonus. Don't worry about it.
Okay, should I just send you the certificate?
Yes, that's it.
Okay, sure. Thank you.
Okay, thank you. Any other questions?
Doctor, may I ask some questions?
Yes. Yeah, sure.
For your recommendation that what is the size, usually size of the image for one patient in a hospital, maybe per year, or the size of the image, the data, that the size of radiology image?
Actually, it's very huge. Right now, it depends on the kind of imaging modality, of course. For ultrasound images, I would say that the usual size is maybe a few hundred megabytes. Okay. For MRI, you're talking about maybe 10 times that. Okay. This is the usual for a single study. Okay. And it depends on the kind of study as well. So basically, within the same modality, you might have studies with a study with very few images, like for example, chest X-ray, for example. And some studies, like with CT, you might have multiple volumes. So basically, it depends on the actual study. So it has very wide variability.
Okay.
Okay. Any questions? Okay, so I'll see you inshallah next Sunday in Bismillah, inshallah. If you have any questions about the project, please don't wait until Sunday. You can contact me anytime, okay? Good luck, inshallah. Assalamu alaikum.